Hello, my name is Erik Cornelisse and I welcome you to this webinar. The topic of today is the iCargo infrastructure, and I will give you a brief explanation what the core concepts are of the iCargo infrastructure and an example of how it can be used. First of all, we have to establish a common definition of what we mean by intelligent cargo. And for our purpose, we have defined it as collecting the information around or about one thing, one object, and provide secure and controlled mechanisms to share that information. In short, we call this the entity-centric approach. If you look at the supply chain, and currently today, there are many systems supporting parts of the chain. Applications built by the responsible organization for peace in the chain. And all these separate systems and applications, well, they can hand over the information to another, but only after a specific system integration project. And it's not only that we want to know or want to exchange information from to our neighbors, to the next organization in the chain, but also across the chain you would like to exchange information. So in theory, you need more system integration efforts than just connecting to the neighbors. And so what we did was add an additional information flow to the existing information exchange and collect information about the cargo, about the container, about the vessel, each in a different but separate electronic document. And this electronic document contains all the information that is available about a single thing. So the current approach is to build systems, computer systems, to support processes, and we extend it with information organized per thing. And this is what we call the entity-centric approach. And this is one of the main things where the iCargo infrastructure differs from the other infrastructures. I called the information is being collected in a electronic document, and this electronic document we call it a digital shadow, because like the real shadow in real life follows the subject, this digital shadow also follows the goods or the container or the truck along the chain. So instead of trying to connect each container, each vessel, or each wagon to each other, which is a very difficult task because there is a huge diversity in hardware and protocols. We upload all the information to the digital shadows. And these digital shadows live at the internet, and it's much easier to exchange the information between the shadows than trying to connect devices, unknown devices, to each other. So back to the definition of intelligent cargo and the essence of our infrastructure. We use the entity-centric approach, but we also use a logistic ecosystem for collaboration. And the aim is to actively collect and control and share information per object, per shipment, or means of transportation. Intelligent cargo and the system is not about artificial intelligence. It's more about the Internet of Things, but you probably get that already from a previous slide. If we look at an historic perspective, we started building software systems to support processes. This is one category of this type of software are the ERP systems, and they are focused to increase the process efficiency. Using a cargo-centric approach, as we did in the Eurydice project, we try to increase the data efficiency, to organize the data in a more efficient way. But along the road, we saw that this is not specific for cargo, but could be used for everything, an entity. So the cargo-centric approach changed into an entity-centric approach. And within the iCargo project, we use this to increase the connectivity. So now, and this is one of the goals of the iCargo project, we are trying to increase the utilization efficiency. By being able to share more information in a more efficient way, we are now able to make more more efficient use of our resources. So we can reduce the amount of empty space, for example. Next step would be to integrate the business services and software services to have a more optimized and controlled supply chain, and to create new services. And the future will be all of this, but then globally. So if we go back to the main problem that we want to solve, that's visualized in this picture. Suppose you are the owner of a company in a supply chain, which is in fact a network. This is being visualized with the red dot. And if you want to exchange information, you can try to initiate system integration projects with your biggest and closest neighbors, the direct partners. But how much effort you spend, you will never cover connectivity with all the participants of the supply chain, especially when subcontractors are involved, or subcontractors or of subcontractors. They are not only changing, but they are also many in numbers. So the problem is that you will never receive, in the current situation, you will never receive all the information that's available because you are not simply connected. One of the things that we try to do with the iCargo infrastructure is to provide a new solution. In contrast to the current solution, which is called the traditional system integration, where two companies are being connected with use of a traditional system integration project, which costs a lot of money and time, the iCargo infrastructure provides a virtual system integration solution, which means that it will be much easier with less technology expertise required and with less cost to connect with each other. Okay, to make this possible, this virtual system integration, we developed a special technical API, and I would like to emphasize the word technical API because in the logistics, a lot of different functional APIs, messages are used. And it would be very convenient and efficient if everybody used the same message standard, but that is something that we cannot enforce, at least not today. So we came up with a different solution and said, well, let's try to come up with a simple technical API that allows you to use your own message standard of choice, but still be able to exchange that kind of information. So one of the things that we did, that we achieved within the iCargo project, is the specification of the iCargo REST API. And this means that you can be connected to the iCargo ecosystem by implementing this API. And you can build a separate software solution called an access point to do that. Or you can adapt your own software, your existing software, to be compliant with the API. And then you don't need a separate access point, but then your existing software will be changed into an access point. We call them access point because they are also a virtual representation of the organization or the truck or the cargo that is subject. But it's not only applicable for things. Also, software services like emission monitoring or logistic chain composition can be part of the ecosystem. And again, if they implement the iCargo REST interface, they can connect directly, and otherwise they need also a separate access point software service to connect. One other thing is that information is not being stored in this ecosystem. It's being exchanged between access points. And if you think that you can just drill a hole and collect all the information that is flowing around these clouds, then you are mistaken, because information is only exchanged between recognized, authorized access points, which can be different in each case. So if you are the owner of a particular amount of data, you can decide which other access points will be informed. So it's not about drilling holes, and unfortunately there is no way to access this digital gold mine. But I will explain this later. I will try to illustrate what we did with one of the pilot cases, and this is the case that we did for DHL, in collaboration, of course, with DHL, regarding packages being transported from Germany to a distribution warehouse in Sweden, Värnamo, and from there it will be delivered to several hundreds of places all over Sweden. And we used a inbound transport instruction, formatted, specified according to GS1 standards. And this is an example of such an XML message. It's the EFTMIN standard message. And in a similar case for Unilever, we used the same message standard, but then an EDIFACT format. Well, in principle, this can all be used, and just as an example that you can use your own message standard and you are not bounded to the iCargo one. So what's so important of this single transport instruction is that it contains information of literally thousands of packages that will be sent from Germany to Sweden per instruction, per trip, per inbound trip. And the different packages are symbolized by different shapes. Yes? Yes? Okay, well, let's try to explain it in a little bit more detail how this infrastructure and collaboration works. With use of a pilot case that we did in the iCargo project. This is the case where DHL is transporting packages from Germany to Sweden. We have a long haul trip from Germany to Värnamo, and from there the packages are distributed to the final destination over more than 200 places within Sweden. And for the information, we used the existing inbound transport instructions, which are based on a GS1 message standard. And here's an example of the XML version of the transport instruction that we used. But for another pilot with Unilever, we use the same message standard, but then in EDIFACT format, just to illustrate that different kind of messages can be used, and the only common denominator is the uniform iCargo REST API. So what is important to understand is that this transport instruction contains information about shipments, and within a shipment we have this transport instruction contains consignments, and consignments are related to shipments, and shipments contains one or more logistic units. Well, these shipments, these consignments, these logistic units are symbolized by different shapes in the transport instructions. And on another time, later in time, for the final leg, for the outbound leg, other transport instructions are used to have more information about the final destination and the shipment to Stockholm or Lund, for example. What I try to explain here is that we have a multiple event situation where information is being provided in parts and provided also at different times. And by using the entity-centric approach, all the information about the same topics, let's say about all the triangles or the circles, are collected in like-named documents. So in the traditional system, you have to parse and store all the information in one large database and combine it. And what we do is we collect all the information per item, per thing, per entity. So how did we deploy this for the pilot? In the orange circle, you see the TMS system of 3M, who is providing the packages. We implemented a simple adapter that was able to provide the transport instruction to something that we call the semantic gateway. And this semantic gateway is decomposing the transport instruction into the smallest information elements, where an information element provides information about a shipment, consignment, and for each logistic unit. This information, this decomposed information, is sent to an access point, and there all these information are stored as different digital shadows of each entity. Then the information will be enriched with information from PTV to find the, well, let's say the GPS coordinates of the final destination. And once the addresses are resolved, we could also calculate how much CO2 emissions will be provided or will be will cause the transportation. Finally, the information per shipment, per logistic unit, including the amount of emission values, will be sent to a web app, or what we did later, we uploaded it to Google Drive. And I will demonstrate that here. Let's switch to another screen. Okay, for a very simple demonstration of how it worked in the DHL pilot case, we go to a demonstration website, which I will unlock in a few seconds for you. So here you see the same deployment diagram as I had explained in the presentation, and on top of each system you see a number, and this number will represent the change. And for instance, the number above TMS will explain how much packages will be sent for a specific transport instruction, and the number above the access point will, for example, explain how much digital shadows will be created. So I will inject a message into this system, and therefore I use a simple web application. And this web application runs on my mobile phone, but if I use that, then you will not see what's happening. This is what you see on my mobile phone. And when I inject one transport instruction, then you see appear where the systems are reacting on this message that I have been injected, and I see more than 1,000 logistic units are being created. No, digital shadows are being created. What you can see here is the amount of shipments the number of logistic units provided by the TMS in one single transport instruction. One single transport instruction is being received and decomposed in more than 1,000 entities. I see 108 addresses are being looked up via Xlocate. It contains 108 addresses to be resolved and almost 160 routes to be calculated. The calculation includes the emission calculations, and then for the shipment, for the consignment, for each logistic unit, the specific amount of emission values are being calculated. And I see that the result is being presented in Google Drive, and we can show this information at my Google Drive directory in the emission directory. And we use this as a very simple way to share information, and I can grant access to my partners to see these emission values as well. For example, here we have the emission values of all consignments, and where you see the original consignment number, and here you see the emission values calculated according to the CEN 2011 standard. In addition, we also have the handbook for emission factors calculated. So here you have the emission value for the inbound trip per consignment. But as I said earlier, we are also able to calculate the emission values per item. So here I have a very small transport instruction with several hundreds of logistic units with an SSCC code. And here we have the same, no, not the same, but the emission values according to the same standard. And the one means for the long haul trip from Germany to Vernamo. And then we have a second emission value for the final delivery from Vernamo to the final destination. And as you can see, we have this information, these emission values per logistic unit. And this in contrast to what's currently possible, where we share information, emission values per year at organizational level. And here we are able to do that at item level. So if you go back to the presentation, I explained that the information will be stored in Google Drive, but it's also available via a web application. And I would like to explain a little bit more about using mobile devices or tablets as part of the iCargo infrastructure. So this was basically the demonstration, very short and simple demonstration about the iCargo pilot for DHL, but it also reflects that it's all happening underwater. There is no human intervention required, otherwise than defining and setting up the proper configuration. Once that's done, transport instructions are automatically being decomposed, and emission values are being calculated. Because it's possible to connect a mobile phone through the ecosystem as long as the mobile phone has implemented the iCargo API and as such function as a micro access point. And then it will be able to receive information from the cloud and send it to the cloud. And well, the animation is not entirely correct because it's sending to a specific access point, and it's getting the information from another or the same specific access point. So to summarize, what you have seen is a logistic ecosystem which is open because everybody can join as long as you honor the technical API. It's secure because information is only be shared between access point being assigned or authorized by the information owner. There is no centralized component being owned by a single company. So nobody is owning or controlling the ecosystem. It contains a publish and subscribe mechanism, but also it supports discovery of services and other organizations. Business software services can be included, and within iCargo we deployed at least 3 of them. We do semantic mediation, and again, this is a topic for another webinar. And most important, it's easy to connect. So even if you don't have the IT knowledge to build gateways or understand XML message definitions, you can just install an app and be part of the system. So this is all about optimization of planning, handling, and use of resources across the supply chain. This is the goal. It's not about optimization of information exchange within one company, but between companies. So this is basically my presentation. What I would like to share about some basics about what makes the iCargo infrastructure special, and I hope you enjoyed it. Thank you very much.